Okay, so good afternoon again, everyone. Welcome to APNIC eLearning web class. Today is the 25th of January in 2017. It's 3 o'clock from Brisbane where I'm conducting this class, and this is again the last topic that we have for the day. So far during the day, we have covered DNS security and also particularly securing DNS using DNSSEC. Now, for this last session, our focus will be out of security, but still about DNS. We will be talking about reverse DNS for both IPv4 and IPv6. Now, who is this session catered for? So, reverse DNS particularly deals with when you're creating, say, DNS records or zone data that is corresponding to your IP addresses, whether it be for its V6 addresses that are assigned to you. So if you have an IP address block that is allocated to your network or to your organization, this will be a good session to attend to. Now, a quick introduction of myself. I think most of you have already seen this, but for those who haven't, my name is Sheryl, and I work as a training officer for APNIC. We are a team that conducts face-to-face workshops to members of the internet community in the Asia-Pacific region. And we have a lot of topics, things like network security, IPv6, of course, routing, MPLS, BGP. We have internet resource management. So please feel free to have a look at our website. It's training.apnic.net and register for the sessions, either e-learning or face-to-face that are interesting to you. Now, for this e-learning session, it runs for 1 hour. I do encourage that you ask your questions on the chat panel if you have any, or basically anything, whether it's a comment or an answer to someone else's questions. Please feel free. Let's make this class as interactive as possible. I will be asking you to fill in a short survey for me at the end of the session. So please be prepared to maybe take a couple of minutes to fill that in. Alright, so now with that out of the way, I would like to get started with our topic. And as I've said, we are going to cover reverse DNS. Now, going to this session, I guess it's easier for us and it's going to flow better if we already have an idea of forward DNS or DNS in general. Okay, so if you do not understand some of the basic concepts of DNS, of course, I will try to tackle some of those here, but you can also go and attend another session that covers DNS basics. That's another e-learning class that you can attend. You can either register for the session or watch our recording in YouTube. So that's youtube.com/apnic training. Now, for this topic, we will be focusing, as I've said, on IP addresses. When you talk on DNS in general, it's basically mapping one resource to another resource. And when we say resource, it can be many things. It can be IP address, it can be domain names, it can be a text file, it can be the fully qualified domain name of a mail server, it can be the R data of a SOA, things like that. So our focus here for reverse DNS is IP address to the domain name. Okay, so in this example, you can see you have 192.168.1.100, or maybe its corresponding IPv6 address, 2001db8::1, and then it maps to this domain, which is svc00 or server00.apnic.net. Now, one thing that you will notice later on, he'll show you the DNS resource record type that covers this. It's actually going to use the same whether you're working on IPv4 or IPv6 addresses. Think of it the other way. When you look at forward DNS, like this one, same thing, right? But this is from domain to IP address. The first one is domain to IPv4. The second one is domain to IPv6 address. So when you create this record in DNS, the first one is actually going to use an A record. The second one is going to use a quad A record. A record is for IPv4, quad A record is for IPv6. For reverse DNS, however, the resource record type that we're going to use for both is a pointer record, PTR records. Again, it's regardless whether you're using v4 or v6, it's going to be a pointer record. So I hope at this stage, okay, I think we've already covered the more difficult topics before in the previous sessions. But here, I hope you do understand the difference between a forward DNS and a reverse DNS. Now, why do we have to be concerned about this? Now, one thing that I always, well, not really complain, but some of my worries, especially in the beginning, I guess now it's mostly automated, but especially for small to medium-sized implementation of DNS, people are always concerned about forward DNS. Okay, we're going to set this resource record, we have this zone file, etc. However, we do tend to forget about reverse DNS. But actually, it's important to also create proper reverse DNS, proper delegation, okay, and basically correct information that goes into your reverse DNS zone file. But why exactly? What are the reasons? Why do we have to bother about reverse DNS? These are just some of the examples. I guess the most commonly used reasons for reverse DNS are as follows. First is regarding services that might have implications if you don't have a reverse DNS entry. It might result to something called service denial. So what is this? For example, look at just a simple FTP, anonymous FTP. Sometimes, if it's configured correctly, these anonymous FTP servers will not allow access from a client with an IP address that is not fully reverse delegated. So what do we mean by fully reverse delegated? For that IP address, I should be able to query the DNS server and it should map into something. It should map into a domain. Okay, so I know from which organization, from which network it's coming from. Otherwise, usually it is either denied or you don't get a response from this particular service. Another one is for diagnostics purposes. How many of you have used tools such as traceroute? There are many other tools that use this, but I guess you can see it very clearly when you do a traceroute. Simply do a traceroute and then the IP address. What does it show you? It shows the networks, the routers, the network equipment basically that it passes through until it reaches the destination. So maybe it hops through 5 different networks, 5 different IP blocks. So it doesn't just give you the IP address. Traceroute in itself, unless you tell it not to, it will try to resolve for this IP. What domain does it correspond to? Then that makes it easier. Normally, if you look at your traceroute, you have an idea where your packet is going. So you will see, maybe say from APNIC, my traffic is going through this upstream provider because of the name. The name, the domain name is usually representative of the name of the company or the organization. Right? So you can easily see that, it's going through this upstream provider, passing through this peer, passing through this IX, and then direct to, say, Google or any other, say, big networks that you want to go to, and then, coming back. So in that sense, it is useful for you when you're doing a simple traceroute. So in general, not just for traceroute, maybe you have, say, a tool that utilizes things like traceroute or even nmap and things like that. It will already give you that kind of information without you manually having to do it. So it's easy. By looking at it, you know that it is going through that particular network. Another one is for spam identification. So there are many things that you have to do to consider an email as spam. Maybe it has these types of attachment, maybe it has some keywords, maybe it's coming from dodgy servers, like you have a list of dodgy servers that you think will be sources for spam. So all of those add up to what we call as a spam penalty score. So what does that mean? If it reaches a particular score, normally you either just drop that email or you put it into quarantine. It doesn't have to go directly to your user's mailbox. So in some ways, protecting your users. So one of the things that you can check with spam identification is if you can do a reverse lookup. So for example, I received a mail. It's coming from this IP address. Is this IP address the mail server for this domain? Again, I received that email. It's coming from example.com, say maybe from Shane@example.com. So is this example.com? What is the mail server for this? Since it came from this IP address, that will be either the mail transfer agent of that mail server, etc., right? And then you can map that. If you can fully reverse delegate, you can see that this IP address corresponds to the mail server for that email. So if it doesn't, then you can maybe consider it as an additional score to your penalty, and so it adds up. So that's one way where you can use reverse DNS for spam. And the last one here is something that's related to resources in general. It's your responsibilities, everyone's responsibility to register, these blocks. Particularly we're talking about IP addresses here, right? So it is responsibility of the members to register these blocks and then make sure that it is properly reverse delegated. So what happens exactly is you come to a regional internet registry such as APNIC. You request for an IPv4 or an IPv6 address. You get your v4 block. At the same time, when you get that block, there is automatically within APNIC, that block will be pointed towards your name servers, towards your machines. What APNIC does, or what all the RIRs will do, is delegate these smaller blocks coming from the big block that we received from IANA. So that's part of the responsibility. Make sure that it's properly reverse delegated, so it's pointing to correct name servers and it's properly configured. So we don't suffer from wrong information in DNS. So with that, let's go to the DNS hierarchy tree. Now, if you have attended the DNS introduction, you have seen this DNS tree. What is this? Essentially, it's like the structure of DNS starting from the root, going to the top level domains, going down, using, let's say, distribution or delegation of smaller child zones to other individuals or organizations. So from the root, you have this top level domain. This is for forward DNS, by the way. You have .net, .org, .com, .arpa. .arpa here, this part, is used for reverse DNS. So you can say that if you look at all the top level domains, whether it's gTLD or ccTLD or the IDNs, .arpa is the only top level domain that contains what? All the number resources, IPv4 and IPv6. So what we're trying to say here, we are imposing or we are creating domains for the IP address, by mapping it into this DNS hierarchy tree. Under .arpa, we will have, or we can come up with, a fully qualified domain name for that IP address. What is a fully qualified domain name? FQDN. That is, say for example, looking at forward DNS first. Let's say for example, I have a domain, it's training.apnic.net. If you look at this DNS hierarchy tree, when I say fully qualified domain name, it's as if I'm traversing this DNS tree from the bottom going to the root. So that's training dot, so the links will be represented as dot. Training.apnic.net dot. So all the way to the root. So you have to have that trailing dot. So that is a fully qualified domain name. In reverse DNS, in IP addresses, we should also come up with something similar. So how does it look like? Let's look at this as an example. Say, what's my example here? I have 202.64.22/24. So I received a /24 block from APNIC. What is the fully qualified domain name for this /24 block if I want to add it into DNS? it's going to look like this. Okay, again, traversing from the bottom going up, that will be 22.64.202.inadra.arpa. Okay, again, all the way to the very top. But what do you notice about this? So under ARPA, where you have all the number resources, you have INADRA, in-addr. This is where all IPv4 addresses will be added. Something that you should know about reverse DNS is it's still very classful. How is that? Notice after INADRA we have 202. That means after INADRA, how many nodes do you have? You have 255. So that pertains to the first octet in your IPv4 address, 202, right? So that's only one node out of 255 possible nodes under INADRA. After that, the next level will be, say, from 202, you should also have about 255 possible values here, from 1 to 255. Okay, so what we have, because our block is 64, so one of those nodes is 64. And same thing going down. So this is level 2, like /16. And then for the /24, again, from 1 to 255 again. And then you have 22 as one of your nodes. So let's say if you have another block, 203.176.189/24. What will be your FQDN? Similar. But in this case, if you traverse this tree, it will be going into this node 203, followed by 176, followed by 189. And if you want the FQDN, it will be from the bottom, again, going all the way to the very top. So a 189.176.203.inadra.arpa. Okay, this is an important concept. Okay, in reverse DNS. So the rest after this, okay, will be very similar to forward DNS. You create your zone files the same way as you do with forward DNS. You create your, basically your configuration. You add your zone statement similar to forward DNS. But the content of your, basically the domain name itself for that IP address will be something like this. You have an inadra.arpa. At the end. Okay? So that is DNS hierarchy tree for IPv4. Now, once you've done that, what are the steps if you are creating your reverse zone? So most of this will depend on what DNS software you're using. Now, in my examples here, we will be using DNS bind. Okay, so most of the processes are very specific to that, but there's also kind of general, so all our DNS software should be following the same thing. So first thing is to create your zone file for your reverse zone. You can call it as reverse zone file, reverse zones, etc. Okay, so you will have an initial SOA record and NS record, similar to forward DNS, and then all the rest will be pointer records. So I guess for a /24 block, you can have 255 entries. So you can already pre-populate it, 1 to 255 pointer going to a generic domain name. So say your domain name is example.com. Since you are not assigning this IP address to a specific service yet, you can just add, let's say, server1.example.com, server2, server255.example.com. And then later on, when you have assigned, say, this IP address to a particular service, say I'm going to use 203.176.189.2 as my mail server, then I will now have a pointer going to my mail, mail.example.com. Okay, so that's basically what you're going to do there. So it's a finite number. However, for a single IP address, same with the rest of DNS, you can have multiple pointer records going to or pointing to the same IP address. Okay, that is always possible. So that is your zone file. Make sure that if you name your zone file, particularly if you're creating it as a text file, Okay, if you're doing it manually, make sure that the zone file is as descriptive as possible. Say, for example, here we're using db.203.176.189. So you can always guess this is the database or the zone file for this /24 block. This is useful, particularly if you are going to have a lot of zone files corresponding to, say, multiple /24 blocks that you're managing. Okay, so clear enough? It's actually pretty straightforward once you already know how things are done with forward DNS. I guess the thing that you have to understand with reverse DNS is the use of pointer record, as you can see it, and also the use or the creation of fully qualified domain names for your IP addresses. This is an example of your pointer record. If you look at the entire, say, name here, that's 131.28.12.202.inaddr.arpa. What's that? That is the FQDN4 202.12.28.131. Okay, you can always just add 131 here, especially if your zone file is already named, your zone name is already named as 28.12.202.inaddr.arpa. So you can just list down 1 to 255 in pointer server 1.apnic.net, etc. Okay, that's pretty much how you do it. This is an example of a complete zone file. Again, notice this is the same as forward DNS. You have here on the top is your SOA record, including timing parameters with similar functions as well. You have your refresh, retry, expire time, and negative TTL. So it pertains to the transactions that are happening between your master and slave servers, or your primary and your secondary servers. How often would they do zone transfers? How often would the secondary server check the primary? Next, you have your NS records. Generally, you want to have at least 2 name servers for redundancy, right? So here we're pointing to 2 name servers that will be authoritative for this particular zone. What is our zone? 1.168.192.inaddr.arpa. So essentially, this corresponds to 192.168.1.1.1/24. Now, all the others after that will be all your pointer records, as I've mentioned, 1, 2, 3, 4, all the way to 255, pointing to your company's or your organization's domain name. Okay, so nothing different, but you only have pointer records after your SOA and your NS record. You don't add anything else. You can't have an A record here, you can't have a quad A or a CNAME record. It's usually just pointer records. Now let's talk a little bit about reverse delegation. Now this is where the confusion is. Sometimes, okay, when you have a block, you think, okay, should I create a reverse zone for this? So the simple answer to that question is, as long as you have an IP address block, either assigned to you, okay, or given to you by your upstream provider or delegated from APNIC or the RIR, then you can, of course, create your reverse zone files. But is there a particular block size for creating them? One thing that we've already established is reverse DNS is still very classful when you're talking about V4, right? It's still very classful, meaning usually we cut it off or we split it using octets, either the /8, /16, or /24. So what happens generally if you have, say, a big block, a /16 block? We normally don't have this anymore, but just in case, say earlier organizations that have been given a big /16 block. So with delegation in this case, it usually comes directly from the APNIC or the RIR, and it delegates the entire /16. What does that mean? When you create your zone file, you only have to create a single zone. It only corresponds to a single domain for this entire /16 block. That is the same for /24. So if you have been assigned a /24 block and you want to create your reverse zones for this, you will only have one zone file, okay, one domain corresponding to this /24 block. That's how you see here, okay, it is classful. So if it's a factor of, okay, if it's on the octet boundaries, then you can create just one zone file for that. Now the question is, what if, say, most of you probably got something that's bigger than a /24 but smaller than a /16? What if you get a /19? Does anyone know, okay, how I can create, or maybe how many reverse zones do I have to create for a /19? Does anyone have an idea? You cannot see that the answer from this slide. You only have there factors of, sorry, not factors, but limits of your octet boundaries, 24 or 16. But what about if you have something in between this, somewhere here? Are you going to have just one, or are you going to have many? If you have a /24, you only have one. If you have /16, you only have one. However, and this might be the tricky part for some of you, if you have somewhere in between here, if it's not within the octet boundary, you have to create more. Let's say, for example, you have a /23 block. A /23 is equivalent to 2 /24s. Okay, so the closest octet boundary is a /24. So when you create zone files, how many? You should have 2. Okay, a zone consists of what parts? So essentially, so what you can think of a zone. So it's basically, a zone is basically kind of like a domain. Okay, but it's an administrative. It has an administrative, what they call it, function. Say, for example, if you're talking about forward DNS, if you have training.apnic.net, right? It's a subset of apnic.net, but it's been delegated to you. So that is your zone. You have to create the zone for that domain. With reverse DNS, it's the same thing. So from APNIC, you have been assigned, say, a /24 block, 203.176.189/24. So you have to create a zone for that IP address block. Does that make sense? So, Abdul, I hope that answers your question. So, basically, that will be your administrative zone. When you have that zone, you create entries or resource records from within that zone. Okay? Okay? So, going back to this, if I have a /23 block, how many zones do I have to create for this? One or many? The thing is, you have to look at the closest octet boundary. In this case, is /24. You'll have to create 2 /24 blocks for this /23. Okay? So if going back to my example, I have 203.168.189.0/23. Okay? What will be my zones? 1 /24, say 189.0/24, that's one zone. Maybe 190.0/24 will be another. So in my, say, in my DNS software, okay, I have to define 2 zone statements pointing to 2, okay, 2 zones, 2 /24 blocks. Okay? You can do this delegation from APNIC, but you'll have to create 2. Another example, say /19. Does anyone know how many blocks will I create? So basically, from this /19, how many reverse zones should I create? Again, what is the closest? You go to the /24 blocks. How many /24s are there in the /19? The answer is you'll have 32, right? So you should create 32 /24 blocks, 32 smaller zones for this /19. Okay, I hope that makes sense, everyone. Now another question, what if you have something smaller than a /24? Now coming from an RIR level such as APNIC, we don't normally delegate anything smaller than a /24. Okay, that's typically the minimum, because also like on the routing table, anything that's smaller than a /24 are usually filtered out. So usually that's coming from an ISP or a local internet registry delegated to their customers. So let's say you're an enterprise network. You go to your upstream provider, hey, can I have an IP address? And they gave you a /27. So what do? Is the delegation done from APNIC? The answer in this case is no. It's going to be between you and your upstream provider. They will delegate that, okay, to you using the DNS system, and it's not going to be done using APNIC portal, the MyAPNIC. This is what we call as a classless in-adra.arpa delegation. You can read more about it in this RFC 2317. Okay, but if you have bigger blocks, particularly it's bigger than a /24 and it's not in the octet boundary, please remember that you will have to create multiple zones, multiple smaller /24s for that to comprise your big block. APNIC and LIR responsibilities. So this is about delegation still. So once you have been delegated an IP address block, again, the system will process such that these blocks will be delegated, okay, and pointing to your DNS servers. Quick question, what do we mean by delegation and how do we do that? Delegation is, of course, when we assign a smaller blocks to another organization, the responsibility is now with them. But if we are the bigger block or the parent zone, we have to point it to that server, right? So we will have an entry, okay? Sometimes we call it as a glue record, added into our zone file that points to that name server. So that if there are questions for that zone, we will tell them that, oh, I'm not responsible for that anymore, so you should ask this name server. That's the referral part. It happens in the DNS hierarchy. So root refers to the top level domain refers to the next level of subdomains. It's the same thing. Now when it comes to reverse DNS, it's also the same. You have a big block, APNIC receive a big block from IANA. From that big, say, /8 or /12 block, APNIC delegates smaller blocks to APNIC members. So once it happens, then the reverse DNS will also be delegated towards your name servers. Okay, that's why it is important that you understand it so that you can provide the correct name servers to the system. Okay, so your responsibility at that point will be, of course, to be familiar with the procedures and how to do that. Address the, make sure that the address are properly reverse mapped. Okay, so we don't have what we call as lame delegation. In APNIC, it's pointing to your name server, but your name server is either non-existent or you don't have that zone. Okay, you're not authoritative for this IP block because you haven't configured it properly. So again, make sure that it is reverse mapped on your DNS servers. You maintain your own name servers. APNIC will only do the delegation. It's not going to be hosted within APNIC. And related to that, as I've said, blame delegation, you want to minimize the pollution of DNS, meaning wrong information, wrong delegation propagated into the DNS servers. Now, how we can do this from APNIC side, it is done using the MyAPNIC portal. So it's essentially creating Whois objects, okay, for the reverse zone. It's still the same as like, we call it as a domain object in Whois. Okay, this domain is not pointing to forward DNS. Okay, please remember that. It is pointing to the fully qualified domain name of your reverse zone. Okay, of your IP address. That's why we still call it as a domain. It's a domain object. So what you do is for that block, you create a domain object in the Whois database, and that is done quite easily using the MyAPNIC portal. You will have to provide the names, again a fully qualified domain name of your name servers. One is okay, but typically it is encouraged for you to have at least 2 name servers. Okay, once you have provided all that information, this is a Whois object. Therefore, to create and update objects, you must have the maintainer password. It's kind of like a protection password for that object. You cannot create and update that object without the maintainer. So you must have that somewhere handy within you if you're going to create this. This is how it's done from the MyAPNIC portal. So it's a very simple form where you can put in the address range. Say for example, you have a /22 block, okay, or maybe you have multiple /24s that are not, announced as a single prefix. So you can add that all here, and then provide the FQDN of the name servers, provide the maintainer, and then click next to implement or to add this. This is an example of a Whois domain object. Notice this. This is the domain. It's 28.12.202.inaddr.arpa. So meaning this corresponds to 202.12.28/0/0/24. Okay. There's a description on what this is going to be from. If you're maintaining a big chunk of IP, normally in this description you provide whether this smaller /24 block has been allocated or assigned to one of your customers. Okay, so again, it's also easy for you for documentation. You have to provide the admin and technical contacts. You have to provide the name servers that will be used for that domain, okay, and other information such as the maintainer. So I guess with regards to the DNS concept, what's important in this part is, of course, to provide at least 2 name servers and make sure that the reverse zone is represented using fully qualified domain. Any questions? Now, if that's already clear, okay, the last 2 slides discusses about creating your domain objects for IPv4 if you get your IPv4 block from APNIC. Okay, so you have those steps of creating the objects using MyAPNIC as an APNIC member. If you got your blocks from your upstream provider, as long as it's higher than /24, your upstream provider will still create that in MyAPNIC because they are the direct APNIC members, but they will still follow the same procedure, same process. It will be done per /24 block. Now, what about IPv6? Now, you've already seen this diagram, right? So you have that ARPA. Under ARPA, you have enaddr. That's for IPv4. Under ARPA, you also have another node. So there are 2 nodes under ARPA. You have enaddr for IPv4. You have IP6 for IPv6. So your IPv6 addresses will be under this. So whatever your IPv6 address there, you will append .ip6.arpa. to complete the fully qualified domain name. You might have heard of .int. Well, I don't have that in this diagram, but there used to be a .int. So it's IP6.int. But that has been deprecated for a very long time. It's generally for experimental purposes. So now you have to use IP6.arpa. Okay? Now, I'm hoping that we're all familiar with IPv6 addresses. It's a bit different. We don't have 32 bits of IP anymore. We're not using dot to decimal format. So it's not going to be exactly the same as IPv4 representation. But in the same way, it really just follows the text representation of your IP. Same with v4. With v4, because you use octets and dotted decimal format, you follow that per octet. Okay, you have those nodes. With IPv6, same thing. This time around, we will be using 32 hexadecimal digits. So it's going to be very, very long. I'll show you some example in a little bit, but the way that you create records in DNS for IPv6 is through a quad A record. Again, an A record is for IPv4, a quad A record is for IPv6 when you're looking at forward DNS, right? So say, for example, I have ns.example.com. If I add an A record, that points to the v4 address. I can also have ns.example.com and then quad A record pointing to the IPv6 address. That's for forward DNS. For reverse lookup, as you have seen in the diagram, to complete the FQDN, it should have an ip6.arpa. But how do we complete that? Let's look at some example. This is an example of a pointer record for IPv6. If you just look at the format, it's very simple. It's very similar to IPv4, right? We don't distinguish between v4 or v6 in reverse DNS. They're all just using pointer records. But notice that the fully qualified domain name here for my IPv6 address is now very long. That's because I have a long IPv6 address. Altogether, I should have 32 hex values or hex digits in here, followed by ip6.arpa dot to complete this as an FQDN. Does that make sense? Okay, so my entry, my resource record will look as like this in pointer and then pointing to, of course, a domain name. Look at this example. 3FFE:8050:T201, etc. ::1. This is an IPv6 address. If you count the number of digits in this address, it's not exactly 32. Okay? But we know that IPv6 representation, of course, from 128 bits when represented in text will be 32 hex digits. But in writing here, because we have a lot of zeros, we were able to omit them and then added a double colon or remove the leading zeros. That's a way to simplify the representation of IPv6 address. However, and please do take note of this, when you create the pointer record from this IP address, it should still use 32 digits. Even though it's omitted in this IP address, when you write the FQDN, it should now add all those zeros that you have removed. So notice here, okay, I still have that. If I write this down, okay, it should be coming from, basically, it's like traversing it down again, right? So 203.176.189.0 in adver.arpa. If you go down, so you're going to look at the higher order bits first, 203, then 176. So it's going to be 189.176.203.in adver.arpa. Same thing with v6. If you go traverse this, you start from the lower order bits, going up to higher order bits, and then add ip6.arpa. So what will my IPv6 FQDN look like? It's like this. It will be 1.0.0.0.0, and then you still have a few zeros there because you have double colon, .2, .4, .0, .6, .8, .1, .1, .0, .2, .0508, .EFF3, .IP6.arpa. So if you follow that, you can see that it's actually like this. I started from here, followed that one, followed by this, .IP6.arpa. So it's very, very long. And then you add your in PTR, pointing to the domain name. So one way that you can make this more manageable is first to subdivide your network and maybe create multiple records or maybe even multiple zone files. So you have a /32 block and you subdivide your network into /48. You can have multiple zone files for each /48 block. Another one is you have a single zone file, but you will create $origin statements so that the rest of the basically the rest of the address will be added into $origin, and you have just a minimal number, maybe the last field, the last 16 bits will be the one that you like increment and then add as a pointer record, something like this. In this case, what we have done is from here up to 1860 up to here. Okay, so 1, 2, 3, 4 fields, which is equivalent to a /64. So for the /64, we've added that as your $origin, and then the last 64 bits will most likely be your device IP. Okay, so this one is the device IPv6 address. This one, added as origin, will be the prefix for this part, /64. So at least it's more manageable to type all of them. Any questions so far? It's not overwhelming, right? Well, you can always automate the creation of these pointer records, but if you're going to do it manually, that's one way to somehow segregate and make this a bit more manageable and easier to understand for your zone administrators. Subnets in IPv6. Well, you still use prefixes in IPv6. Okay, so your /something in v4 still holds true. So you have, say you have /24, /16 in v4, right? In v6, you have something like /32, /64, /48. Generally, your smallest prefix will be /64. So that's why in this example that I showed you, we're using /64. But if, say, you receive a yes, that's /64 in the example, you're right. If you are using, say, you have been assigned a /32 block, say, from APNIC, and you're going to like create your reverse zones for that entire /32. The easier way is to segregate it into smaller /48s. Okay, so you're only concerned with smaller blocks than having everything, all of these in a single file. Maybe in the beginning you will have just a few resource records in this file. However, as your network grows, particularly we're talking about IPv6 here, right? So as your network grows, this can become a very, very big file. So it's easier to segregate them into smaller ones. I guess for big, large networks, you don't really want to do per /64 because that will be very tedious. But per /48 or maybe /56 is a bit more manageable in some ways. Questions on IPv6 reverse DNS? Okay, so this is just a wrap up of all of that discussion earlier. Existing A record will not accommodate 128 bits, so we're using quad A. Quad A record will represent 128 bits. Reverse mapping is not in adra.arpa. We're using IP6.arpa. Okay, multiple addresses are possible for any given name, same as in IPv4. You can assign an A record and a quad A record for a given domain name. So you say you have ns.example.com. You can have an A record for that. You can have a quad A record for that. You can have both. You can even just have an IPv6 address for it. It's all up to you. You can also assign separate domains for IPv6 and IPv4. Say, same machine, okay? But you have, say, a different name, like same machine. So it has an IPv6 address and an IPv4 address, but you're naming it differently in v4. Maybe in v4 it's named as v4 that example.com. In v6 it's named as v6.example.com. That's a totally different domain name, but it corresponds to the same machine because it's pointing to this different IP address. It doesn't really matter. They're still considered as autonomous in itself, like by itself. This is an example of a forward zone using A record and quad A record. You can see that here. Same domain name, host 2, just 2 records, 1A and one quad A record. This is an example of a reverse zone. Okay, again, similar to your other zones, it will be SOA record, NS record, and then all your pointer records. But notice these pointer records are now using IPv6 FQDN. And that's it. That's how you create IPv4 and IPv6 reverse zones for your DNS. Again, for v6, it's quite tedious to do this. Okay, so some strategy would be good if you're going to do that. Okay, strategize maybe per network, per subnet, etc. Are there any other questions? So we've already answered a few. I think most of the questions in the chat have already been answered. So just to wrap things up, this is the survey link for you. Please click on that link to answer the survey for me, please. And then for the slides, you can download a copy of the slides from this FTP page. It lists all the PDFs, all the presentations that we have covered for today. Any more reactions and questions from the chat? If not, I think we can end here. Thank you very much, everyone, for listening in. It's a very short presentation, okay, for reverse DNS, not quite as big as the others because most of the concepts have been explained in forward DNS already. So this is complementing that. So we can end there. Again, please do the survey first before closing this. Otherwise, thank you very much for joining our session. It has been a really good session. Thank you for joining us. Hope that you can register for more sessions. Go to training website and register for the topics that you are interested in. We have quite a lot of new topics that we are introducing. Okay, MPLS, a few different courses on MPLS there. We have started, I think, an introduction to SDN. So if you have been with us for quite a while and you think you've already seen most of the topics this year and a lot of like last year as well, we have introduced quite a few new topics that you will enjoy. So thank you very much for joining us, and I hope that you can still join us in our next e-learning sessions. So it's goodbye from me now, but hope to see you again soon. Bye-bye.